Hello and warm welcome to this iQPilot and iQMobility webinar, where we will answer the question, are we ready for fully autonomous public transportation? Today we want to share with you our latest research findings on autonomous vehicle technology and fully autonomous vehicle transport systems. The findings are from the two research projects, iQPilot and iQMobility, that we have been running from 2016 to 2020, together with our partners that are also with us here today, both on stage and online. My name is Camilla Lode. Normally, I work as a business developer for autonomous systems here at Scania, but today is not like any other day, so today I'm your host for this webinar, and I am sitting here on stage together with my colleagues from Scania, George Dibben and Jonathan Mossberg. You have been project leaders for these two projects. Under normal circumstances, we would have done this as a live demonstration, but due to the situation today in the world, this time we chose to do this virtually. But behind me, or behind Jonathan and George, you can at least see our two beautiful buses that we have been working on during these 4 years and that we are quite proud of. And you will also see them in many of the films we will show today. But now we will start by having a look at today's agenda. So in the coming 2 hours, we have experts and exciting speakers from both the academia and industry that will give you insights into the research results within these 6 themes. We will then have a 1-hour lunch break and start again at 1 o'clock with a number of breakout sessions. Here you're welcome to join any of the 4 parallel sessions, and if preferred, even jump in between them. So by that, I think it's time to get started. And I actually start directly by handing over to you, George. Can you please tell us a bit about the background to the first project, iQPilot, and also please tell a bit about yourself.
Okay. At the moment I'm the project manager for iQPilot, and I started putting the project together already in 2014. And at that time, Scania was working with another FFE project called iQmatic, which was focused on autonomous mining. And I would say this has been actually the area which has really caused the autonomous area to expand at Scania. This was very much more towards off-road applications. And when we then came into starting iQPilot, what we really wanted to do was actually start to build up the technology that we needed to go out into more sort of urban areas with more structured roads. And so that's where we started, and now here we are today on what is actually the very last day of these projects.
So what other partners have been involved in these projects?
So we've had Veoneer, who brought in their stereo camera technology. At the start of the project, they were actually ought to leave, but they've had some changes there. We've had then Ericsson, where we've been working together in proof of concept technology for 5G. And then finally, we've had KTH, the technical university in Stockholm, where we've had a PhD student who's been working in situational awareness. So that's the 3 partners we've had.
Okay, thank you for this introduction. And before moving on, could you please tell me a bit about how have this area evolved at Scania during these 4 years?
If I put it like this, I think when I started, it was just a handful of people working in it, maybe 10 or 15. And in this 4 years, it's expanded to be now more than 250 people working in the autonomous area at Scania as engineers and in the management structures. But then there are other functions even beyond that in the organization, whether it's your business solutions area or other supporting areas. So I think it's been one of the areas of biggest expansion actually in the last 4 years. So it's been very exciting to see actually how much things have changed in that time.
Yeah, it sounds like an amazing development, I think. Mm-hmm. And Jonathan, can you please say a few words about yourself and also the other project, iQMobility?
Yes, thank you, Camilla. iQMobility is kind of a sister project to iQPilot, and that has run in parallel since the start back in 2016. And me myself have been the project leader for this project since October last year only. And while iQPilot has been doing research on the autonomous bus itself, we in iQMobility has more looked into the public transport system from a more holistic point of view. And tried to find answers on questions like, in a city like Stockholm, for example, what of the existing bus lines would be most beneficial to automate first? And also, how should fleet management and transport planning be handled for these autonomous buses? And to find answers on these questions, we have cooperated with KTH as well, the Royal Institute of Technology in Stockholm, but also with INIT, supplier of transport control systems today, and currently the supplier to Stockholm Public Transport. And in addition to this high-level fleet management and transport planning, we have also looked into motion planning and coordination methods. And this is to make sure that these autonomous buses in an efficient way can handle the very often crowded and narrow areas around and inside the bus depots. Yeah, where very often tens or even hundreds of buses in parallel go in to get washed, maintained, etc. And on this topic, we have cooperated with experts from Örebro University.
Okay, interesting. And I'm also aware that one part of your project isn't directly related to the transport system, but more to the autonomous bus itself. Can you explain a bit about that?
Yeah, that's correct. That's correct. And one important thing, of course, when we don't have a driver in the bus anymore, is to make sure that the bus still can interact with people and vehicles surrounding it on the streets. And here the external HMI team at Scania has done very interesting research by simulating several different external interfaces and then tested those on real users. And our interaction designer, Adelina Autarka, won't join us here in this session of the webinar, but will have a presentation on this topic in the breakout sessions this afternoon. So don't miss the chance to learn more there.
Exactly. Don't miss that, really. And by that, let's move on into the first segment. Yes, as I said, now we will move on into the next segment, or the first segment actually. And it will be presented by Erik Jinelius from KTH and Hassan Jamil from Scania, who I have with me both here on stage. And we also have with us Roxana Hess from INIT, who is joining us online. Hello, Roxana.
Hi.
So we will now turn our focus on how automation can be implemented in the public bus transport network of a city like Stockholm. So Erik, first of all, very nice to have you here. Can you first tell us who you are and please present yourself?
Yes, I'm an associate professor and the head of the division of transport planning at KTH. And there, my colleagues and I have worked on how to best use the potential of autonomous buses at the strategic level. And in this project, we have developed methodology for network design of public transport that incorporates the autonomous buses.
Okay. Can you explain a bit further what your research has entailed?
Well, we have tried to look how to best design the lines and as well as frequencies and vehicle sizes in the public transport network to utilize autonomous buses. And we have a short video clip here that shows some of our work.
When we think about automation of vehicles or buses, we think about small vehicles which can drive passengers from their origin to their desired destination. But on a large scale, these solutions are currently neither technologically feasible nor have legal approval and can therefore not be realized. In this work package, we have investigated how the advantages of autonomous buses can be used already today, with the goal of transporting passengers efficiently in urban environments. The core concept to achieve this is the enhancement of the existing public transport system with autonomous buses. To answer questions like, which bus lines should be automated first? Or, what are the changes for passengers, operators, and manufacturers when exclusively operating autonomous buses? A simulation-based optimization framework has been developed. This framework allows to efficiently evaluate large-scale public transport networks with detailed analysis of vehicles, passengers, and infrastructure. The main results of this work package show an increase in service frequency for autonomous bus operations, which implies consequences for many stakeholders. For example, reduced waiting times and larger vehicle fleets. In the second part of this webinar, we will present detailed information about the research questions, the developed framework, and results of the case studies in Stockholm.
Erik, how would you advise the city of Stockholm to decide where to operate an autonomous bus line?
First of all, I think it's important to consider the line not in isolation, but to see its role in the overall transport system, where travelers can have different options and transfer between lines and so on. And then I would say that to get the most sustainability impacts out of a new line, it can be good for the city to consider areas where there is currently not very good public transport services in order to attract travelers from private cars. On the other hand, in order to get the most economic benefit out of the services, it can be good for the city to consider existing public transport lines where we have high frequencies and high travel demand in order to make sure that many travelers receive the benefits of the autonomous buses.
Mm. And how do you expect the people to experience this change? I mean, have you envisioned the impact on the autonomous transportation on the everyday user?
I think there will be some transition period where travelers will have to become accustomed with autonomous buses and learn about safety and security around the vehicle and when boarding and alighting and so on. But after that process, I think travelers will come to consider the general attributes like travel times, waiting times, and crowding on board. And in all these aspects, I think that autonomous buses can improve these aspects.
Okay. And how about the manufacturers that will produce these autonomous buses? How do you think it will affect them?
I think there are these factors concerning safety and security that need to be handled. There are, of course, things related to communication and control systems. But then also, I think autonomous buses have this potential of requiring new vehicle sizes, for example. So I think we can expect a higher demand for smaller types of buses that will be important for the manufacturers to consider.
Okay. And last but not least, I have to ask about the operators. Any impact on them, or how will it affect them?
I think it will imply some changes in the traffic control centers for the operators to be able to work with autonomous buses. But once that is in place, I think they will offer much more flexibility to manage delays and disruptions in real time, assigning new missions to vehicles, and also start working more with demand responsive services, for example, where vehicles can respond in real time to traveler requests.
Okay. Thank you, Erik. And now about the bus operators, over to you, Roxana from INIT. Hello again. Welcome to our webinar. Can you please first tell us where you're calling in from?
Yeah, so I'm calling in from Karlsruhe in Germany, which is the headquarters of INIT.
Okay.
So I'm now in the home office, but in Karlsruhe is the headquarters.
Yeah, please tell us more about INIT and your role in this project.
Yes, so I'm a project manager in the research team of INIT, and INIT is a supplier of integrated planning, dispatching, telematic, and ticketing systems for buses and trains. We are assisting more than 700 transport companies around the globe. And in the iQMobility project, we were responsible to integrate Scania's autonomous buses into INIT's fleet management system, which we call mobile ITCS. A fleet management system helps public transport companies to operate their buses. And in the next video, we see a short explanation of what a fleet management system of a public transport company has to do, and we see how we integrated Scania's autonomous buses into the ITCS.
In the iQMobility project, INIT is responsible for the integration of the autonomous buses into the fleet management system. Generally, a fleet management system is installed in the control center of the public transport operator, and it is used to manage and monitor buses and trains on their routes. If, for example, a vehicle is delayed due to heavy traffic or other incidents, the dispatcher can react by informing a connecting vehicle to wait for transferring passengers. A fleet management system is also essential for passenger information. INIT's fleet management system is called Mobile ITCS. In iQMobility, we establish a connection between Scania's integration portal and the ITCS. We use SEN-approved standards for the data exchange, ZIRI for real-time information like vehicle position, NetX for schedule and route information. This allows to manage and monitor Scania's autonomous buses in INIT's system. The buses follow the schedule received by the ITCS and continuously send back location information. In the second part of the webinar, we will answer questions like: what are the challenges of integrating autonomous buses, and how is the data transmitted and what is it used for?
Roxana, can you explain further why it's necessary to have a fleet management system to organize the buses? Why can't they just drive around in the city following a schedule?
Yes, so driving around following the schedule works exactly as long as there are no incidents or delays. In reality, unfortunately, there are constantly issues, for example, due to heavy traffic or even worse, accidents. So take Stockholm as an example. There are 2,300 buses in the city, so the chance that one is delayed to whatever reason is quite high. And this then has an impact on the following buses serving the same line, and also on buses serving lines which are interconnected. So obviously, as a passenger, you would expect the bus of a connecting line to wait for your bus in case your bus is delayed only by a couple of minutes. And for this, you need a monitoring system. So in case of accidents, this would be even worse because you might need diversions of some kind. And for this, it's also crucial to at least know where your buses are and to be able to inform them about new schedules, best in an automated way, simultaneously informing then your passengers about the changes.
Okay, thank you, Roxana. Now I'm quite curious to know more about the role of Scania regarding its connection to INIT's system. So over to you, Hassan. Could you please, before answering this, just introduce yourself also to the audience?
Yes, thank you, Camilla. So my name is Hassan Jamil. I work as a product owner at Autonomous Transport Systems at Scania. And together with INIT, we have been able to transmit data between Scania and INIT in real time following a ZIRI protocol. And this has given us the ability to follow a timetable set by INIT and run a bus line in real time together with them. So what we have done is basically to execute the missions that INIT have set and report everything back to INIT so that they can monitor our buses and also handle deviations. At Scania, we have something called Scania ICE, which stands for Intelligent Control Environment. And what we can do with that is that we are able to connect with different third-party companies so that we can offer different solutions to different business areas. And we have the possibility to do it in an easy way so that we can help our customers and offer different solutions for them.
Okay, thank you, Hassan.
Thank you.
So in the next video, I believe we will be able to see how this joint effort that we've just discussed works in practice. That is, we will now see how Scania ICE receives the travel mission from INIT and sends it to the bus to depart. And at the first stop, we meet George again. Yes, so we will now shift our focus a bit from the autonomous transport system and go more in depth into the autonomous vehicle itself and how the capabilities of the vehicle in the system. So, in short, we are moving on to the iQPilot project, and I have with me here on stage both you, George, you're back again, and Laura Dalcol from Scania. So first I will turn to you again, George. Can you please tell us more about the next video that we will see?
Yeah, I would describe this next video as being our main showcase video for iQPilot. It shows how we've been able to run together with INIT to a timetable. But I think it also shows a lot more than that. It shows a lot of the other sorts of scenarios that we've also been able to bring into this project and that we've been able to have running out on our test track. One thing I would say is obviously we've had the COVID-19 pandemic come up. So when we were planning this in the first place, it was more supposed to be that we would have everybody who's watching now invited in to come and have a ride. Didn't work out like that, but I think I'm very happy with how the video turned out. Going into it, we had the idea that we would have our one bus from iQPilot, our one autonomous transport system from iQMobility, and then one continuous take for everything that we're about to see. So let's see how it turned out. So the demonstration starts with our autonomous bus in a small depot area, where at a scheduled time the bus pulls out and starts a run to the very first bus stop to pick up the first passenger. We will be following the journey of the bus with Scania's intelligent control environment ICE, which can be seen in the top left corner of the screen. We also watch through the forward-looking camera, which is a continuous shot, but sped up to make the journey go faster. Around bus stops, we'll also see in the top right corner our external HMI concept, which provides contextual information on the outside of the bus to other road users. Here, as we start to move, we're actually matching speed against another faster moving vehicle on the left, and then giving way to it and moving behind it onto the left side. So here it moves to the left because the vehicle knows that it can only reach its final destination in the left-hand lane. As we come up a bit further, then we reach a vehicle in front, and we're following it at speeds between about 30 to 50 kilometers per hour. And you can always see the speed of the vehicle in meters per second in the bottom right-hand corner of the screen. When we're coming a little bit further along, we can focus a bit on the perception of the environment in the top right-hand corner of the screen, and also the representation of the roads in the onboard HD map. And it's this combination of sensing and mapping which is what allows us to do things like drive into this pocket bus stop on the right-hand side. One thing to notice during this whole drive, the safety driver doesn't need to touch the steering wheel, but neither the brakes or the accelerator, but they do occasionally touch buttons here and there. Having a full autonomous control of every function on the vehicle is still an area in development, but this is something more towards productionization. At the next bus stop, several of the passengers getting on and off have been given cameras to capture their journey, and again to emphasize that this is one continuous drive for our vehicle. As the passengers get on and off, the doors open autonomously, and this is on a simple timer, and it's one of the future research areas for Scania, how to handle getting passengers on and off the bus and providing a more complete experience for the passengers. Next up, we're going to come to an electric charger, where the rest of the passengers are going to get off. The laboratory bus is not actually an electric bus, but the buses that we will be running from after the summer in 2020 will be autonomous electric buses and will have much more advanced versions of our autonomous software and more advanced sensors. As we come around the corner in the distance, we can start to see a dark grey building in the distance, which is Scania's wind tunnel. Now, on top of the wind tunnel, there is a prototype 5G antenna from Ericsson, which was installed for various experiments in the iQPilot project, and that will be presented separately. Now, as we come around the corner in the distance, we can start to see a roundabout where the other two demonstration vehicles that were seen earlier in the demonstration are already driving around. And the key thing is that our autonomous vehicle is constantly monitoring how it thinks that these two vehicles are going to move. So it stops for the first one on the roundabout, moves in behind the first one, but in front of the second one, because it understands based on the situation and its own analysis that it's able to move in between the two vehicles in the time available given the speeds that they're driving. Now actually here we're coming up to the very last stop in this simulated bus route. A normal bus would probably be spending the rest of the day going round and round, driving different routes and servicing different passengers, but for today, for the purpose of our demonstration, we're actually heading back to our depot area. One thing to mention about this depot area, today we drive through the depot on a predefined route, but we also have developed an open area planner that can navigate more freely through this kind of non-structured area. But for now, we're actually coming back to our starting point, where we are parking ourselves between the two buses that we started with, and actually that's the end of our very simple demonstration.
George, I have to ask you, say at the end of this video, this is just a simple demonstration. To me, this looks quite impressive. Can you comment on that?
I think what I would say is, for a human, if they were driving this would just be what a normal bus driver would be doing on a day-to-day basis. And so from that point of view, yes, it would be a simple demonstration. I think in terms of an autonomous vehicle, this has taken really a lot of technology coming into it to actually make this happen. And I think we have a slide we should be able to see very shortly. So we had two main areas that we had as showcases for this, which was our so-called bus stop pilot, which was just being able to go in and out of different kinds of bus stops. And also city pilot, which was just the general ability to be able to drive on roads and interact with other vehicles. But of all of the technical work packages that we have also had in the project, basically all of those contribute in some way to those main technical work, the main demonstrations. And the way that we actually put this together was we generated a scenario catalogue for all of the different scenarios that we wanted to achieve. And these were based on a specific route out in Södertälje, outside our main technical centre, heading into town. We put those into our scenario catalogue and then laid them out into areas where we could actually test them on our test track. Most of them we managed to get into this main sequence we saw now. Well, I think we'll see a bit of other footage here and there for other bits we didn't manage to fit into this route. But yeah, I mean that's really how we brought all this together. Yep.
Mm. But how come you did this demonstration on a test track and not out on a public road?
I think one thing to remember, these buses are research vehicles, so at this stage they're not productionized, and the way that we've been approaching things is we do our research first, and then we pass on the work that we've done technically into more pilot projects where we do more sort of small scale applications after we've done the research area. So really that's where we're headed for next, to actually be able to put these things out into real situations, but in sort of closed pilot projects for specific areas where we have scenarios that are similar to the sorts of scenarios we've already developed.
And why do we still have a safety driver in the driver's seat?
Good question. I would say that from our point of view, having still a safety driver there really speeds up our development. I think it's very different if you have to make the entire system operate and be able to deal with every single situation. So the way that we've ended up putting our vehicles together is we've had a safety concept which allows us to really just focus on the development, so that we don't have to worry too much about if something sort of doesn't work 100% perfectly, because the safety driver is always able to have control of the vehicle whenever they need, and the vehicle's always going at speeds which are appropriate for them to be able to handle the vehicle if it doesn't do exactly what it's supposed to. However, obviously, to go forwards out onto pilots or onto public road, we need to have made a step upwards in the functionality. But again, as I say, that's really where we're heading to after this project.
Okay, thank you, George. Super interesting. You also pointed out that there are a lot of different working areas in iQPilot.
Yeah, and I think it's fair to say we don't have enough time to focus on all of them today. So really, we've picked out a few key areas to focus on, and I think that's the time when I would actually like to introduce Laura for the situational awareness area.
Hi Camilla.
Hello, Laura. Welcome to our webinar. Can you first maybe explain a bit about your role?
Yes, sure. So right now, since 2 months, I am group manager for perception and localization. But before that, I was a senior engineer in situational awareness, and I was contributing in this area.
Okay, great. And can you please give us a short introduction to the video I think we're about to see?
Yes, so in this video we will see what situational awareness is and how it enables the autonomous vehicle to make well-grounded decisions and to plan for a safe and efficient motion. And by the way, in the video you will see Christopher, who is the product owner for situational awareness, but right now he has just had a baby, so today I'm here to represent this area. So now we can have a look at the video.
An autonomous vehicle has many types of capabilities, which can be to sense the environment, to reason about what will happen next in this traffic scenario, and also to act and control the motion of the actual vehicle. As we humans do as well, we need to sense our environment, to reason what will happen next, and also we need to select an action, what we would like to do next. And my area is about reasoning. So I get the current traffic scenario, meaning more or less where are all the vehicles in the scene, where are the pedestrians, what is the state of the traffic light, where do you have the pedestrian crossings and so on. And then we use that information to process how the agents in the scene will behave according to each other. Say for instance that you have a vehicle approaching a traffic light with a pedestrian crossing and a pedestrian beside it. Will the pedestrian enter the road or not? And that's our mission and job, to distinguish what will happen next and to what type of probability, so that the next part in the chain can take the action whether we should drive or not.
The plan's responsibility is to plan a route for the bus to drive in a safe, efficient and comfortable way. The planning algorithm has several layers. In the first, it will initially try to find a path forward using the information from the map, where we have the road network, traffic information, and other static information. And then it will adjust to the current dynamic environment, where we have other vehicles, pedestrians, and also static obstacles. In the demo, we could see that before entering the roundabout, the bus stopped to give way to the bus in the roundabout. This is an example on how we can predict and use that information to drive and to plan the route.
So Laura, after watching this, can you explain why situational awareness is such a key focus area for the future of autonomous vehicles?
So situational awareness is about understanding how the environment evolves over time, and it's to be able to predict how the traffic agents will behave in the future. So if we want the autonomous vehicle to interact with the environment, we need to have the skills to reason about that. So without situational awareness, we won't be able to drive at all.
Okay, what are the challenges and trends in this technology area?
So we are seeing many trends and new areas that are very interesting. First, the perception and sensors that have more capabilities. So we want to be able to process more data, and this sets a higher demand on the computational platform and performance. We see a lot of new trends, for instance, in the optimization techniques. So a new way of tuning cost functions based, for instance, on inverse reinforcement learning. Of course, the big trend of deep learning and GPU-accelerated method. And when it comes to more traditional physics-based model, then we want to be able to tune the parameter of those models using, for example, big data sets and modern estimation techniques.
Okay, I also understand iQPilot has a PhD project within the situational awareness area.
Yes, exactly. So Jonathan Mentori is a PhD student at KTH, Robotics, Perception and Learning, and his PhD is about predicting the trajectories of the vehicles that are around the autonomous vehicle, and to see how this vehicle will interact with each other and with the autonomous vehicle itself. This is quite interesting because it's the first AI-based work that we have started at the department. And this really set an example and indicated that we have identified this as a very important area. And we have recently started 2 other PhDs. And it's really worth to mention that one of these PhD looks into V2X and how information coming from other vehicles through connectivity is really an important area to investigate. So how different vehicles will transmit their local information to increase the awareness of the system.
Okay, thank you, Laura. Thank you, George. Is there anything else anyone of you would like to say before we move on to the next segment?
Obviously, thank you, Laura, for coming to present today instead of Christopher. Big congratulations to Christopher as well.
Oh yeah, congratulations, Christopher. Okay, thank you. So by that, we now move on to the next topic, to see what happens in the control room. And we will start this segment by watching an introduction video on Scania ICE.
In the early stages of the development of the autonomous transport solutions, we identified the need for a system to support management of large fleets of driverless vehicles. Scania ICE, or Scania Intelligent Controlled Environment, is the tool for safe and efficient management of autonomous transport operation. Scania ICE is offering interfaces to all surrounding systems and humans interacting with the system. And one of these interfaces is the one offered for operators in the control room, from where large fleets of driverless vehicles are monitored and controlled. What you see here is the second physical installation of such a control room that we have set up in order to evaluate new functionality of the different modules of ICE. From ICE, missions are sent to vehicles, and these vehicles are then continuously reporting back their status, including, of course, also possible deviations that might occur along the transport mission. As an operator in the control room, you then need to understand the situation remotely and then act on it, all in order to ensure safety and then resume normal operation. And in order to efficiently utilize a fleet of driverless vehicles, you also need a system to optimize the distribution of transport tasks to individual vehicles. That, of course, also including replanning in real time what each vehicle should be doing. Together with the company INIT, offering systems for planning and dispatch of public transport, we are now exploring the new challenges and possibilities that we face introducing driverless vehicles to public transport. The guiding star when developing the autonomous transport solution within Scania is safety and efficiency. And Scania ICE is a key concept in order to realize that.
So for this segment, I have new guests with me up here on stage. It's Anders Stellberg and Martin Castor, both of you working at Scania. First of all, nice to have you here. And I will start with asking you, Anders, can you please maybe introduce yourself? We have seen you in the video, but please say just a few more words about yourself.
Sure. I'm Anders Stellberg. I'm currently the Chief Product Owner of the Scania Intelligent Control Environment. So also part of this team developing this solution for Scania.
Mm. We just saw this introduction, as I said, and this is really something new, I believe, outside of Scania's traditional offering. Can you please tell us a little bit more about ICE?
Sure. You're perfectly right. This is definitely something totally new. I mean, introducing autonomous transport in our customers' operation is really adding possibilities, but also a lot of challenges to our customers. And obviously, Scania needs to then adjust our offering to meet those needs, let's say. I mean, removing the driver is really a big thing. And then not only in terms of the technical aspects of actually doing the driving task, the driver, there are so many other aspects that the driver needs to manage. That could be everything from communicating with passengers in the transport system or the back office, or managing deviations that might occur. What we are doing now, developing this Scania Intelligent Control Environment, is really making it possible to introduce autonomous transport into public transport operation by adding interfaces, both for users in the system, but also for other systems, in order to take care of all the aspects connected to autonomous transport, not only the driving task.
Okay. One really interesting interface is the one towards the operator in the control room, I think. What do you believe? Will Scania in the future offer control rooms for autonomous solutions?
Well, I really hope so. I mean, Scania has a long tradition of developing modularized solutions where we combine different parts into a solution which fits the customer. This strategy is something that will remain as our strategy, let's say, on this system level. So we will have customers that has legacy systems that they want or need to keep in their solution, or we will have other customers who have certain preferences for sourcing parts of the system from a specific supplier other than Scania. And then we will have most likely customers who would prefer a complete solution from Scania as well. And either way, we really need to understand the whole context, the full ecosystem in every domain that we are targeting, really. And this is also why we are active in research and developing within this area.
Mm. What's your view on how Scania ICE relates to what INIT has done in the iQMobility project?
Yeah. So INIT really provides the link for us to the rest of the ecosystem within public transport operation. They are contributing with the functionality such as transport planning, scheduling, generation of timetables, information provided to the passengers in the system, and more. What we aim for Scania is to find a holistic solution to fit the need of the customer, and we will provide those solutions either by ourselves or together with partners. And in this specific context, we have found INIT to be a very strong partner within the domain of public transport. And what we have done now in our project is to evaluate a lot of different alternatives in how to design the interfaces between our system and how they should be working together.
Okay, well, thank you very much, Anders. Nice talking to you. And I think now we've understood more about how Scania ICE, what it is. So now I'm going to turn over to you, Martin Castor. Could you please introduce yourself and also the work you have been involved in related to the so-called control room?
Sure. So I've been active as a researcher in the field of human-machine interaction, user experience or human factors for the last 20 years. And in this, I've been part of the team developing the human-machine interaction concepts for the ICE system.
Can you explain us a bit more what this control room is all about?
Well, the short answer is that it's all about human automation teaming. We need to provide the information and control options that enable the operators to stay in the control loop. And as you will see in the breakout sessions later, it's a complex flow of information, tasks, and interdependencies that we need to design for. We need to identify them and design for them. And that's what the HMI part is all about.
Yeah, this reminds me a lot of like an air traffic control tower. Have you looked into other domains?
Mm-hmm. Yeah. So the team that has been part of this development effort have experience from air traffic control, from process industry, nuclear power plants, and military command and control systems, as well as a solid base in human-centric research questions. And even though we're developing something new here, it's of course very interesting to look at the other domains and see compare and contrast with what they have done.
Mm. Mm. What do you think are the most interesting research areas within this field?
So, designing for a future world where the specifics of use cases and constraints are unknown to some degree, that's always challenging. Given all the things that could happen during real operations, the capability of maturing technology, and all the combinations of human-machine interactions, that creates quite a large solution space that we need to explore. So one of the questions that we've been thinking a lot about is how many vehicles can a small team of operators actually control, given different autonomy levels and different transport systems. Another question that we've paid quite a lot of attention to is how we support the transition for the human operator from a supervisory controller, managing a fleet of vehicles when everything is running smoothly, into a technical troubleshooter in case a vehicle needs support, and then back again, as smoothly and efficiently as possible. And during the operations of today, we can rely on the competent driver to manage all those deviations and special situations that might occur. But for autonomy, we need to design for that beforehand. And on the road towards autonomous driving and, in the end, autonomous operations, there are many interactions that need to be managed, which the driver solves today. So indeed, very many interesting research questions there.
Absolutely, I agree. This is for sure a whole new way of transportation, I think. So thank you, Anders and Martin, for joining us. We should also mention, I believe, as you already did, that if you are more interested in this topic, there will be more about this in one of the breakout sessions during the afternoon. But now it is time for us to take a short 5-minute break, and we will be back in about 5 minutes. Welcome back from the break, and we will now get started directly by moving into the next segment, 5G and connectivity. And now on stage here, together with you, George, who we know by now, and Håkan Olofsson from Ericsson joining us online. Welcome, Håkan.
Thank you. Pleasure to join you.
So let's start off with you, George. Can you give us an overview of the work that has been done together with Ericsson during the iQPilot project?
Sure. Just to give a bit of background, around the time when iQPilot was starting, this was around the time when Ericsson was working with a lot of its core R&D for 5G. And one of the things they were working on at the time was proof of concept for 5G and doing various different kinds of installations for that. And given that iQPilot was actually sort of a good match for them to understand a bit the needs of the automotive industry for 5G, then they very kindly installed one of their proof of concept antennas for us on our wind tunnel here at Scania, quite early on in the iQPilot project.
And what have you and Ericsson achieved with this prototype installation?
We had two main areas that we've worked on. The first one of these was remote drive, which is very much connected to the last section that we looked at, which was another methodology for interacting remotely with some of our autonomous vehicles in the field. So I think we have another video now where we can see a bit of that.
Making use of coming 5G communications, Scania, in collaboration with Ericsson, is developing a system to remotely control self-driving vehicles.
So remote operation is probably our fallback solution to when the autonomous vehicle are not able to either legally or technically able to operate. One possible scenario could be autonomous vehicles driving along the road and it's noticed something it doesn't recognize and it can't pass without breaking traffic rules or other violations. So it will stop in front of the object and report back to the human operator that can assess the situation. The operator can then either override that obstacle or take control remotely, which we are doing in this case.
George, how does 5G help with this area?
Yeah. I think there were two main motivations for using the 5G concept for this area. The first one was network slicing. And what this means is that when you have a safety critical application, such as remote driving, the vehicle is able to be connected with a prioritized signal between the remote drive station and the vehicle itself. And so what that means is that you have a priority to make sure you always have a good connection. And instead of having to, for example, be balanced against the needs of, say, all the people watching YouTube on the bus and things like that. So that was one of the core things. And then the other core piece that it brings to it is the low latency. So the point being that you would have a very low latency for the driver who's trying to steer the vehicle remotely, but also a very low latency for the video feed from the remote vehicle back to the driver, because that's the key aspect for the driver to feel like they are still connected to the vehicle in real time to what's actually happening, and that's the key to making it actually work.
You mentioned earlier that there were two areas that you had worked on.
Yeah. So there's the second area which we've been doing in the last year. This has been experiments to do with transmission of data through vehicle to network to vehicle, and again we have another short video about that we can show now. Yeah, so the point was that all three of the vehicles that we had in our demonstration scenario have all been connected through this antenna that we've had from Ericsson, and they are then continuously sending position information between the vehicles in the scenario. So for example here we can see as we come up to this roundabout, as we pause, there's a vehicle in the foreground, but our vehicle can still perceive the vehicle in the background behind it on the roundabout. So this really is only possible by actually making the connection of data between the vehicles to pass the information through the network. Maybe one thing to say, I think that this is just an initial proof of concept for us, I think one of the challenges going forwards in this transmission of information vehicle to network to vehicle or vehicle to vehicle is how to make sure that this is scalable. So this is a very small setup here where we have 3 vehicles all sharing information, but one of the challenges then is, okay, what happens if you need to have a whole city connected to be able to execute this kind of scenario? And so I think what I would say is, I think in the future it's probably more likely that we would have things like connected junctions, especially on the sorts of scale of deployments that we're talking about in our sorts of pilot projects. And what I mean is connected junctions where it's the junction itself that detects other vehicles in the environment or other people in the environment and transmits then through the network back to the vehicle what's happening in the surroundings.
But what benefits has this given?
I mean, obviously, for us, this has allowed us to develop scenarios that are beyond the current direct line of sight capabilities of our vehicles. So, as Laura was mentioning earlier, this V2X area is one of our upcoming areas. So, we've started off with just a few number of vehicles in the scene, but we also have plans to go forwards also with having, for example, pedestrians in the scene, maybe using information from their mobile phones or, as I say, connected junctions. So this is really the start of this journey, I think, for V2V and V2X type technology.
Okay, very good. Now, Håkan, over to you. Sorry, you've been with us for a while now without being properly introduced, I believe, but now please introduce yourself.
Yes, I'm joining here from my summer home in Katrineholm, on the verge of internet coverage, so I hope you can see me.
Absolutely.
I think most of you know Ericsson. We are now very active in 5G, and we have 95 commercial contracts on 5G. We are live in 40 countries. And my role in that is I'm working at the business area networks, where we develop and build our network equipment for 4G and 5G. And my program that I run is responsible for understanding, identifying, and provide decision basis for the technology that we need to bring 5G to new use cases. So we have brought internet to the mobile phones, but now we are very focused on bringing 5G to industrial use cases, including the transportation industry. And then I also have a role at KTH. So I'm co-director of the Integrated Transport Research Lab, ITRL, where we do research together with Scania and KTH.
Okay, great, Håkan. Thanks for this introduction. So now, where do the results that we have seen from iQPilot fit into Ericsson's vision of connectivity for the automotive and road industry?
Yeah, it's very interesting. So the results from iQPilot show a couple of examples of the power of connecting vehicles. And we actually have a picture that we can use as backdrop to see where this fits into the total vision that we have. If you have the picture up now, we can see that the 4G, 5G infrastructure along roads and streets will have to support a wide diversity of service types. Everything from basic telematics, for example, connecting engine data and feeding that to the backend Scania cloud. Another example is the infotainment, so providing Wi-Fi to passengers in the vehicles, all the way to very advanced service types like helping the driverless vehicles to move around, as we saw in the video, or remotely supervise them from a control tower, and including the remote drive that we also saw. So those are a few examples, and I think iQPilot fits very well in. A couple of other examples that you see in the top left, for example, we need to connect the road infrastructure, not only the vehicles, and traffic signs, etc. need to be connected, and sometimes cellular is the best option for doing that. And another example in the bottom right is the connecting the actual goods on goods vehicles and the parcels, so we can track them and trace them. So that all that together creates a very diverse need for connectivity along the roads and streets. And our vision is that our 4G, 5G system should be able to take care of those and separate the needs for different services between the service segments.
How do you see the progression of these areas that we've seen when we move on to driverless vehicles?
Yes, that's a very important thing because we have a situation now where most of the new vehicles, both commercial and private vehicles, are connected to via our systems. But it's very different in maturity. So what we see today is telematics, the simple feeding data from the vehicles to the cloud for better understanding, and also maybe software downloads, upgrades of the vehicles. We also see infotainment, of course, already now. Then we have an interesting development around the advanced driver assistance systems, helping the driver to drive more efficiently and more safe by providing information from other vehicles and from the road operators, like traffic light information and things like this. This is now sort of happening, and most of these services can actually be run on the 4G system out there, which is already installed along many roads of the world. So we don't have to strictly wait for 5G for anything to happen. But then when we are moving into a driverless world, then these assistance services that I talked about, the ADAS or advanced driver assistance, that will move to actually assisting the vehicle itself, like you saw with the positioning data in the demo. And we will also need to remotely supervise the vehicles and the fleets, and then we need very strict latency, and we also very carefully need to separate different traffic needs from each other, so we know that we have bandwidth when we need it for the advanced services. And that is when 5G come into play, and with both low latency and the separation or slicing that George mentioned. Okay. And I will actually talk about a little bit more the progression here, and with selected examples in the breakout session in the afternoon as well.
Okay, very good to know. But tell me also, how do you analyze and investigate the needs from the automotive and transportation industry to understand how those needs can be met by 4G or 5G for driverless vehicles?
Yes, so it's important to start safe, right? So that's when the research projects such as iQPilot come in. So very carefully understanding the basic principles and the basic requirements that the connectivity should satisfy. And starting in very fenced off, confined areas, both like we have done in iQPilot, but also learning from the confined area systems that we see emerging, like mining, like harbors, like airports, where we have a very simple, relatively simple traffic situation, and also a possibility to control the connectivity situation. So if we have a local installed system, we can control the radio environment, so we know that we have coverage everywhere we need, for example. Starting there, learning from that, and then move on to bigger pilots in geofenced areas, special bus lanes, for example. Still a little bit simpler than just bringing everything on public streets everywhere day one. So there is a progression, a lot of trials and hands-on experience to understand the connectivity needs for different situations. On top of that, we work with regulation and policy and use cases and requirements with the ecosystem globally. So we have 5G Automotive Association, 5GAA, which is an important organization for that, feeding in requirements on the communication sector. And then we also I want to mention the academia here. So we have this ITRL collaboration with Scania, Ericsson, KTH, which is a very strong way of connecting the Swedish players in the ecosystem for this.
Okay, thank you, Håkan. I think now time is running, but does anyone of you have anything more to add, maybe before we move on to the next segment?
Yeah, I just wanted to say Ericsson has been an official partner towards iQPilot, but it's also one where it's been a non-funded partner, so all of the investment has been purely from Ericsson. So I really think we have to say big thanks to Ericsson for that contribution. So thank you.
Yeah, likewise. Thank you. We would like to thank you for the opportunity to be part of playing around with your buses, and also for the ongoing tight collaboration we have in the ITRL context. And we believe strongly that it's worth it because the connectivity will help transforming the transport system to both more safe and a more efficient and sustainable industry.
Yeah,
thank you.
Thank you.
And thank you again.
Yeah. No, I just wanted to say that we've seen now some of the V2X perception, but I really want to show a bit what we've done with our real perception, with our real sensors.
Thank you, both of you, again. And now let's move on to the next topic, and let's have a drive in Södertälje. Now I'm here on stage with you, Patricio Valenzuela from Scania, and we have also with us Jonas Hammarström, with us online from Veoneer. Hello, Jonas.
Hello, Camilla.
So we will start in the studio with you, Patricio. Can you briefly introduce yourself and what you do?
Absolutely. I am a product owner for perception, localization, and digital maps in the research section for autonomous systems at Scania, coordinating the technical development in the field.
Okay, and can you tell us what is it that you and Veoneer have been doing together in Södertälje?
Yes, with our colleagues from Veoneer, we have taken the reference route for Södertälje that is in the context of the iQPilot project. And we have focused mostly on the red route in the slide, which is straighter lanes with oncoming traffic and bus stops. The purpose of that test was two. On one side, we would like to test the performance capabilities of the stereo camera vision developed by Veoneer, and on the other side as well, testing the performance of our own perception algorithms at the Scania. So probably while we look at the video, we can go through and describe a bit more what we have been doing. So environmental perception is about understanding the vehicle surroundings in real time. And for that, we use onboard sensor data like LiDARs, producing point clouds with range detections, radars, producing detections with range and also relative speed information, as well as cameras, producing classified objects and the type and the distance if possible. With these three sources of information, we combine in what is called a statistical sensor fusion to produce estimates in real time for making autonomous driving happening. And in the footage, we can see the output produced by the environmental perception algorithms developed by Scania. We see in this blue square box the static environment estimation, and the green boxes represent the dynamic estimation in real time. And these outputs are crucial for our colleagues working in situational awareness, motion planning, and control, to make use of this information and determine what is the best action at every time.
Okay, thank you, Patricia. I think this is really, really interesting. But one question, we see in the film here that we have a lot of different types of sensors on the bus, and you talk about sensor fusion. Can you please explain to us why so many different types?
Absolutely. So to introduce the answer, we first need to understand what will an ideal sensor in the context of autonomous system should provide or will provide. And such sensors should provide detections of the range, relative speeds, and classes in real time with low latency and high accuracy. Unfortunately, the maturity of the technology right now is not at that level, and even though I think it's almost impossible to reach such as a sensor modality. And hence, we need to use the current sensor modalities that produce the different source of information, and every of them has its benefits. For example, LiDARs are pretty accurate on the range estimation of the detections. Radars are accurate when it comes to relative speed information. and cameras are accurate when it comes to object classification. And we need to take care of producing an estimation combining these three sources of information.
So in the future then, would you say that then we would be able to remove some of these sensors?
Well, it's an interesting question, but we will see what the future says to us. But I'm pretty optimistic that we can integrate more and more sensor modalities as time goes.
Thank you very much, Patricia.
Thank you.
Now over to you, Jonas Hammarström from Veoneer. Hello, Jonas again. Where are you calling in from?
Hello, Camilla. Nice to be here. So today I'm calling in from my home office in Linköping here in Sweden. But in Linköping, we also have our Veoneer office developing the active safety cameras for the global automotive market.
Please tell us a bit more about Veoneer.
Yes, so Veoneer is a global automotive supplier. We are developing active safety systems and sensors. And I am based at our office in Linköping, as I mentioned, where I work as a director of pre-development for computer vision. So I'm responsible for developing next generation active safety camera systems. But Veoneer is developing many different types of systems and sensors, including, of course, then the vision sensors, but also radars all around the car, LiDAR sensors, driver monitoring systems. We also do airbag control units, and we develop a central compute system with active safety controls software. So a complete system supplier, as you can see.
And what has been your participation in this project and also the results?
Yes, so we have been working together with Scania by bringing results from a stereo camera development into the iQPilot project. And as you will see today, the stereo vision is a very good sensor for active safety and automated driving system, thanks to its performance and reliability. And my colleague, Carl Munsin, who has been working on this project, he also joined Scania on the recent data collection. Carl is now having his first holiday week and cannot join us in person today, but we have a video where Carl is describing some examples of the detection capabilities of our stereo camera. So Carl will now describe what you can see with our camera in the following video clips. So let's view the video.
Veoneer's stereo vision gives an extra dimension to camera images with distance information in every pixel. This gives redundant and complementing information within one sensor. Top left image shows the camera image with object overlay from detection algorithms running on mono-camera images. This is what exists in mono cameras and is based on trained neural networks and classifiers. Lower left image shows the stereo image with distance coded in colors. Red means close and dark blue far away. Top right image shows flat and drivable surface in green. Red means occupied area by any large or small obstacle which should be avoided. This information is extracted from the stereo image and is determined only from the geometry of the scene. No training of classifiers or networks are needed. Lower right image shows a three-dimensional view of the scene with the position of every pixel. Lane markings and road boundary from mono and drivable surface from stereo are overlaid in the view.
Jonas, please tell us what benefits does stereo bring to urban driving?
Yes, so a traffic environment and especially urban driving is very complex and it's not easily predictable. So we need sensing systems that can detect objects in any type of situation to support the control system in the best way. And as Carl mentioned, our stereo camera, it gives an extra dimension to the standard monovision systems with train functions, using, for example, deep learning, where you get functions like object detection, you get lane detection, road boundary, and so on. And in addition to these systems or functions, the stereo camera also uses sensing principles that provides distance information, and that improves accuracy and reliability beyond the mono cameras. So stereo is capable, for example, of detecting small objects and the road boundary and the drivable surface using this distance information. So in summary, stereo vision provides very reliable detections by combining trained monovision solutions with stereo distance estimations in one sensor.
And what do you think Veoneer has learned through your work in the iQPilot project?
Yes, so we have together with Scania gained a better understanding of the scenarios which are of importance for autonomous driving of buses in the city traffic. And as mentioned, we have collected a common scene catalog of different urban scenarios in this project, and we have evaluated a stereo camera in these scenarios. So, for example, we have developed and evaluated drivable surface detection and small object detection functions, and been able to take further research and development steps during the course of this project.
Thank you very much for joining us today, Jonas.
Thank you.
Thanks. So in the context of this topic, I believe, Patricio, that we would also like to share some of our learnings from another FFI project that we have ongoing called IQ Deep. Can you please tell us some more about this?
Indeed. So we have been cooperating along with our colleagues working in the AI team in the research section at Scania in this project called IQ Deep, as you mentioned, Camilla. And they have produced synergies with the iQPilot project. They have made use of the buses to collect data and produce segmented images and classified objects from a camera platform in real time. And that is thanks to the use of methods and techniques comprising machine learning and artificial intelligence approaches mostly, and all of them are data-driven. So probably we can take a look on the video that our colleague Ali Riesa produced, and he will provide more details on the subject.
IQ Deep as a project started in January 2019. It is a project funded by FFE, and it is a collaboration between Scania and Linköping University, where we have 2 PhD students. The main objective of the project is to use AI for autonomous driving. This includes the entire pipeline, from data collection and logging to annotating the collected images, to training deep learning models based on the raw data and annotated images, and then evaluating the trained models, and then finally deploying the trained models on the vehicle. What you can see here is the result of one of the modules of this project, which is semantic segmentation of camera images. So here, the trained neural network segment the pixels of the camera to 13 classes. And this will later be used by other modules in the perception pipeline of Scania autonomous driving.
So for explaining a bit more on the purpose of the IQ Deep, we show here in the slide the project packages. In a nutshell, or in a summary, we can say that the focus of the project is on building tools for data logging, segmentation for doing then model training, and there is also a part of the project that is research heavy, and that is allocated with PhD students.
Okay. Can you give us a brief summary for the overall perception area?
Yes, I would say perception is a crucial part of autonomous systems. It enables the awareness of the system about the surroundings and trying to make the best decisions in real time. And I would like to invite the audience to listen to the technical presentations this afternoon, where we will provide more details on different topics.
Thank you very much, Patricio. And now, I believe it's time to bring the bus back home to the depot. We now have George with us back again, and welcome João Salvado from Örebro University.
Thank you for having me, Camila.
Hello. George, what can you say about the challenges of autonomous driving in a depot?
Yeah. I think I would say the challenges are somewhat different from our structured road scenarios. In Some areas it's a little bit more like what we were doing in our mining areas because we have so much less structure often in the environment. We've got a lot more just moving vehicles around in enclosed areas. One thing I would also like to say, in our sort of main sequence that we showed earlier, we had our scenario where we had our main autonomous bus parking in between two other ones. So we obviously have to deal with this kind of parking scenario. In this case, I would have liked it if we'd managed to have more time to move them a bit closer to each other, but that's for next time. But we do have some other scenarios where I think we've done enough work to actually show a little bit what we've been doing, even if it's not one of our main showcases. So I think if we can just have a look at the video that we have prepared. So what we're seeing here is the same depot area as we were earlier starting and finishing in, but this time we're driving through it as an open area where the vehicle knows its final destination, and then it's just able to plan its route from A to B. We've also been doing other scenarios, such as this autonomous fuel station scenario here, where we've just simply laid out a road for the vehicle to know where it should stop and start and be able to navigate through some of the typical scenarios that we have in a depot. But one of the other areas I would also like to highlight is our work, where we'll see in a second, for landmark-based localization. So as we see here with the poles on the left-hand side being detected. And the reason I specifically highlight this is many areas in a depot can be inside. So, for example, workshops, washing stations, various other areas. And that's a very specific challenge for us because we don't have line of sight for GPS. So this is why we've also developed this landmark-based localization solution, with one of the main goals being able to drive inside. So I would definitely point people towards that part of the second part of the webinar for people to understand a bit more how we go about driving inside in this kind of area.
Mm. Yeah, I guess one of the challenges in a depot is how you maneuver in such an area.
Yeah, I mean it's many more sort of tight areas with sort of different kinds of obstacles, and we have things like even doorways going into workshops and things like that that you have to handle. This is another case then where we again need sort of very accurate perception of what those obstacles are in the environment and very precise controls and motion planning. And again, I would suggest if people want to know more about how we actually perform those sorts of activities, that they join those sessions in the afternoon in part 2.
Mm. What type of management systems, if any, are needed for the autonomous bus to function in the depot?
Yeah, so we've got a slide about that here. And I would describe operation in a depot. This is also very much like a different kind of autonomous transport system than our main drive cycle. Typically in these depot environments we have a depot management system. So for example, we might use the one from INIT together with our autonomous bus, and then again linked together through our ICE portal. So you need all of these elements to make a fully operational transport system in this kind of area. The other thing to mention, because of all these vehicles, which are literally robots moving around in very enclosed areas, we've also been working then with Örebro Universitet, sorry, to actually have a look at the challenges of moving these robots around in these confined areas. So I think that's a good time to go back to João. Hello.
Indeed. Hello, João. Would you please introduce yourself to us, and also please let us know where you are calling in from?
Yes, I'm a PhD student at the Örebro University, and more specifically I worked in a multi-robot planning and control lab, and as many of us in these days, I'm also working as a home office. And here at our lab, we mostly deal with the problem of coordinating fleets of robots. And this is a multi-level problem that I'll not go too much into detail, but we prepared a video that is voiced by our lab leader and my supervisor, Federico Pecora. And in this video, he describes the coordination of multiple buses that maneuver in a bus depot, in a real bus depot that exists in Germany, Leipzig, Lindenau, but I'll pass it to you to show the video.
When not in service, autonomous buses go to the local bus depot. The Lindenau Bushof in the city of Leipzig is one such facility. Many operations happen in a depot. Buses are fueled up, washed, they receive maintenance, brakes are checked, and the buses are parked. Depots are typically tight spaces, and things can get quite crowded. In these environments, it can be very difficult for buses to maneuver concurrently. At Örebro University, we have developed multi-robot motion planning and coordination methods for this purpose. The operations to be carried out on each bus and the order in which these should occur are decided by a depot management system. These assignments may be planned in advance or can be made on the fly as the buses come into the depot. The multi-robot motion planning and coordination methods we have developed ensure that buses never collide and that the fleet keeps moving at all times. Our algorithms are designed to make as few assumptions as possible. This makes them applicable in a wide array of application settings. The approach works no matter what the shape of the environment, nor does the environment need to be discretized in any way. It doesn't matter how, when, or where buses are assigned to go. If it is possible, the system will compute a path for them to get there, in safety and without blocking others. The dimensions and kinodynamic models of the autonomous vehicles are also a parameter that can be specified by the user. No particular assumptions on these are made. Our approach guarantees liveness of the fleet, which means that it will avoid and actively resolve via replanning any situation in which robots are deadlocked or block each other. The system we have designed for iQMobility has been validated both formally and empirically, which means that our theoretical claims of safety and liveness are backed up by extensive empirical testing. We have also found that the approach scales well to several dozens of autonomous vehicles, rendering it ready for action in real-world bus depots.
Thank you for showing us this film, João. But please now also tell us, why is coordinating autonomous vehicles in confined spaces such a challenge?
If you think about how these vehicles work, they have non-trivial kinodynamic, as Federico just told. And this entails that maneuvering in these spaces is a complicated problem. And if you think about these buses, have a huge footprint, and they would sweep large swaths of spaces, which, as George said, will make this space very constrained. And furthermore, we have unstructured spaces. Now, when you put several buses working on these conditions concurrently, this is specifically challenging because these motions now need to be coordinated in such a way that we can ensure safety. And moreover, and as you probably could see in the video, it is easy to see how small groups of buses can end up in a deadlock situation or further problems. And these are specific situations that require from one or even replanning. If you think about how humans think about these problems and solve these contingencies, even in the traffic outside, they usually communicate between drivers. Although now that I'm thinking, like here in Örebro, they don't beep so much as in Portugal, but they will find another ways to communicate their intent. And this is exactly how we try to address these issues in our work. So in our work has made fleets of autonomous buses capable of doing so in a similar manner. None of these can be pre-planned, these contingencies, and rather all these decisions are made on the fly and asynchronously.
Why is it important to be able to do this on the fly or asynchronously?
Yes. If you think about in the morning, we had these different depot management systems. For example, we had a talk from INIT, and they have their own criteria for deciding which bus should go where, and these are not a fixed setting. And in some depots, these decisions can be made, for example, by some human manager that is working in this depot, or in others, there is some optimization system that can decide where these buses should go and when, and or for example, how do they get back to the depot at the end of the day, and in which order they do so. But most importantly, we have to think that things in real life, they don't always work according to plan. I mean, we can think about buses breaking or mechanics getting sick, and or the pavement needs to be redone, and the list keeps going. So it's very important that we can, that your software and your strategy to tackle this problem is able to accommodate such requests and such contingencies on the fly.
Thank you, João. Thank you, George. Is there anything more any of you would like to say before we close off this section?
I think one thing on our side, on Scania's side, obviously this work on strategic planning has come much further than we've managed to scale up the number of vehicles that we have to be able to test it. But I think it's something that we can look forward to in the future with your work, to be able to see this at some point in the future when we do have enough vehicles that we can actually really go out and test it with.
Yes, George. Before I finish, I myself, and also in the name of Örebro University and our lab, I would like to thank the Scania team in Södertälje, that we have been, especially me, be working in close connection with us in the past years. And more on the point that you made, George, in the afternoon talk that I'm going to make, one of the things that I'm going to address is specifically the work we have conducted with you, and mainly on the Scania Del Route testing depot, which is a similar setting that was shown on the video for the Leipzig bus depot. So if you are invited to come, thank you.
Yep, thank you.
Thanks again to both of you. And yes, again, so if you are interested in learning more about this technology, please join the breakout sessions after the lunch break. But now we have come to the final part of this webinar. So to give a broader perspective of this topic, we have now invited Anna Pannestål from ITRL and Ulf Ceder from Scania, we can see here on the screen. And I also have with me on stage, Jonathan, welcome back again, and George. So a special welcome to both of you on the screen.
Thank you. Okay, Anna, you can start, Anna.
Yeah, technology is not working. Thank you very much for inviting me, Camilla.
I was afraid that we had no sound there for a while, but oh God, good we have.
Thank you here also, and nice to hear all the interesting presentations and new insights from this webinar.
Anna, you are heading ITRL, where I know you have many research activities ongoing within this field. Can you please describe what you do for our viewers so we'll learn a little bit more about you?
Yes, so ITRL, Integrated Transport Research Lab, is a research center at KTH where we work on how new technology can contribute to a sustainable transport system. So it includes, for example, how users and companies will adopt to the new technology, how it should be implemented, how new business models should be implemented, what are the barriers for upscaling, and so on. And one important part here is also to keep the system perspective. With driverless vehicles, it can be more attractive, it can be cheaper on the vehicle level, but that might lead to more usage of vehicles and more traffic and more congestion and more energy consumed and more emissions. So it might be sustainable on the individual level, but it might not, if we don't use them properly, be sustainable on the system level. So we always keep this system level in mind also.
Thank you, Anna, for this. And how about you, Ulf? What are you doing on a daily basis?
Yeah, part of my time I spent together with Anna as a co-director in the management team, also with Håkan from Ericsson, as you heard earlier in the presentation here. Otherwise, I also work in our research and innovation office at Scania and leading the work of future transport systems and solutions. It means like a lot of collaboration, coordinating initiatives and projects around on a system level. Also integrating like new technologies with new business models. So yeah, you can say, to summarize, exploring and understanding future of transport.
Thank you. I think then we all understand now that you both have deep insights into the transport ecosystem. So I'm going to start off now by asking you, Anna, what do you think are the main challenges towards an autonomous public transport system?
Yes, so I would like to highlight three main challenges. The first one is on the system level. So how does a sustainable system really look like? We might need to rethink what we think is a good public transport system. New partners, new business models, how should it be designed? The user needs to be combined with the society needs and the operator's needs. So designing this and maybe rethinking the sustainable system. Another challenge, I think, is the competition from private driverless cars and taxi services. If we come to a future with driverless vehicles, it might be very cheap and very convenient to drive a private car. For example, if you are on congestion on Essingeleden in Stockholm, if you can just put on the iQPilot in the congested parts, it's quite okay to drive the other parts. So it doesn't even have to be fully self-driving, but only manage certain situations to be very attractive. So when developing the driverless public transport, we will have to compete with the private cars that will also be much better than they are today. So that's a second challenge, and actually in research studies we have seen that especially in the central parts of Stockholm and other cities, driverless taxi service would be very, very competitive and attractive compared to public transport. So we might even see an increase in using private cars and single operated cars in contrast to public transport. And the third challenge, I think, is that we need to, and that's also a solution to the challenges, that we need to start with a problem that we want the driverless vehicles to solve. I'm sure that we can find and should find applications where the driverless vehicles can contribute already before they are fully driverless everywhere and all the time. And I think the depots that we heard about, that is one very attractive such example where they can contribute a lot even before they are fully driverless. So yeah, keeping the system level, designing the system, be aware of the competition from driverless private cars or driverless cars, and solve the right problems, find the problems where to start.
How ready do you think we are for this? And by we, I mean society.
I think we can start. We are ready to start now. If we start, as I said, if we start with the problems where, or the challenges where they can contribute already now, it will of course be a long journey to the nirvana, fully driverless society. And there are of course a lot of barriers and challenges on that journey with legislation, with technology, with service design, etc. But we can start the journey now, and I think it's important to already now think about how will the long-term sustainable system look like, and then start to implement and start to do things already now.
So basically, we are ready to start the journey, or we have already started the journey. Yeah.
Yes, exactly.
So over to you again, Ulf. What do you think are the main challenges for Scania from a transport systems perspective?
Yeah, first, I think what Anna mentioned also is also a challenge for Scania. I mean, understanding the right problems, or understanding what problems or pains the technology can solve for our customers and for society. So that is kind of on a system level, or transport system, transport ecosystem level. Second one is related, I think, but it is for us to be fast enough in developing and scaling up new technologies and new solutions. And for both of this, we need, I think, to be even better in collaboration and in partnerships, because this is nothing we can do ourselves. We have a history of developing our own technologies, our own solutions, but there is in future there is not room for this, I think. So, yeah, I think so. In general, I think this is if I say the three, from my perspective, the three main challenges.
So if we go back a bit to the technical point of view, George, how ready do you think we are for operating autonomous vehicles in a public transport system? And this time, by the we, I mean Scania.
Yeah. I would actually refer back to the previous answer that I think we're ready to start. I think what we've shown today is that we've shown our proof of concept and our minimum viable product for being able to integrate a bus into a transport system, for it to be able to operate without the driver having to intervene. And I think that's a really, really powerful start. I think, on the other hand, if you look at it like this, we're at the moment looking at how it integrates with today's transport system. The autonomous transport system, that may change, and I don't think we really know yet how that is going to actually change. I think if we look at a lot of our interfaces with cities at the moment, they're still looking to do their first deployments out in sort of existing systems as we've been working in today. So I mean, we're ready to start with that sort of level of operation. And I think, as many people may already know, we're already working towards pilot projects with this. I think the one of most note at the moment is what we're working towards in Qatar in 2022 at the World Cup, where we aim to have a fleet of buses operating in a system in a city area. So yeah, I mean, we are ready to start, but we're only at the start of this journey, I think.
But exactly, you mentioned Qatar. I believe there we will actually be driving in sort of real operation with real passengers. Yeah.
And okay, it is more of a semi-enclosed area, but it is an area where we really will be driving out with other vehicles in the area. One of the things where it's aimed is to have various types of infrastructure adaptations to make it easier and simpler, and Yeah, I mean, but this is the way we go forwards, is finding areas where we can drive with the level of technology that we have, and progressively building up more and more functionality over time until we have a driverless system.
Okay, thank you, George. So we discussed challenges and readiness so far, but how do we see the introduction of autonomous transportation affecting jobs in the future? Could you please, maybe Ulf, elaborate a bit on this?
Yeah, I think the most obvious thing that you often hear is that autonomous vehicles will delete or reduce the jobs for drivers. And this is probably true. But what will happen, I think, this will be balanced also with new jobs in like control environments that we heard of earlier. And also the task of vehicles, keeping them on the road 24/7 all the time, will also create new jobs, more advanced jobs. So summarize, I don't think that jobs will disappear, but they will change. Probably more high-tech jobs also. So in general, I think this is also very good because the job of drivers is not always good either. So I think the conditions will be better and change. But we have to educate and train them in new skills.
Mm-hmm. Because I actually hear quite often that we have a shortage on drivers in many parts of the world, also here in Sweden.
Yes, and that's true. It's the same, I think, all over the world. But I believe that the automation and digitalization and so on will make the new jobs more attractive. So that's my belief.
Mm. Anna, back to you again. I really have to ask, we are in the middle of a crisis, a global crisis. What could the effects be from the corona pandemic on the development of autonomous systems? Have you done any research on this?
Yes, we haven't really done research on how this pandemic will affect autonomous public transport systems. But we are currently analyzing data from Sweden and Italy, where we investigate how people change their behavior. And we see a lot of reductions in traveling, for example, for commuting and shopping. Even more interesting, I think, is that several of the respondents state in the survey that they are fairly likely to keep some of their new habits to a relatively large extent. We are investigating what parts even more in detail, of course, but already now that we can say that public transport demand probably will change in the future. It might be a reduction, and I think this speaks in favor of driverless vehicles, where you can have smaller vehicles operating where there is a lower demand and meet the lower demand more in the outer parts of urban regions or outer parts in the transport network. So it will probably lead to a change in public transport demand. It might be a reduction. I've heard numbers of up to 20%. If people start to not commute to work and work from home instead. In another study, we have seen that the reduction in public transport during the corona pandemic is not evenly spread among different demographic groups. And we see that it is a tendency that people with lower incomes continue to use public transport and still have the needs. And thus I think that if driverless vehicles can motivate that we can use smaller vehicles without the driver, public transport could contribute to social sustainability. and to provide a better service to the lower income groups. So I think that's also an interesting aspect. But there are, of course, many more lessons to learn about the effects of the corona pandemic on public transport. But I think one thing that we also should remember is that now we have changed our behavior in quite short time, and it's also a good opportunity for us to rethink and revise how we're traveling and recover or adopt to a more sustainable transport behavior after the crisis. So I think that's a message to all of us, regardless of whether it's autonomous public transport or not, that we could take this moment to recover to a more sustainable transport system.
Indeed, I totally agree. Back to transport system research then. Ulf, what do you see as our essential next steps?
Yeah, I think listening from today also, you can reflect on that. There are still a lot of challenges, research questions to be researched, also on the technology side. So I don't think we have finalized the research either in technology. And especially we're coming to the more complex environments, like in cities and so on, there are still a lot of research to be done. Otherwise, I think, again, coming back to that, I think we need more research on system level, and that includes also like HMI or user interaction, both with passengers, with people around, and so on business levels, on behavioral change, because this needs a behavioral change also in the society, as Anna was into. But also then what ITRL is doing also for us at Scania is the more integrated transport research and analyzing also how to scale up and implement new technology in the society. And I think one more thing that is we haven't heard so much about, but that is also the impact on the logistics and mobility systems that could also influence like the size and the design of our vehicles. So I consider that also as an important research question.
Okay, thanks, Ulf. And back to you again, George. What activities do you have ahead of you to make the transition to fully driverless vehicles?
A lot of research is the simple answer. I think we've got still a long way to go with perception. I think if we look at the results that we've had today, with our sort of minimum level, this is without what we would call almost our 2D sensing platform. So we have research ahead of us into our 3D sensing platform, like on our second bus. We've got a lot more work ahead in situational awareness and decision making. Basically, these sorts of decisions about how we drive. We see more and more, like in all of these areas, we have more and more artificial intelligence and deep learning. And I mean, this presents new challenges also with safety that maybe people weren't thinking about in previous years, just because of how much deep learning, for example, is coming into this, and how you understand the decisions behind what a vehicle is actually trying to do. One of the other things I want to mention on the vehicle level is also when you take the driver out, okay, we need to potentially have more understanding on the vehicle level about what's happening inside the vehicle. And this is something where we really need to go forwards with it, but we're only at the start, I think, of even that journey. So research, I think.
Yeah, it sounds like we will be busy.
Yes.
So Jonathan,
yes.
Question to you now then.
Yeah.
From your perspective, what are the remaining prerequisites for an autonomous public transport system in operation?
Yeah, I mean, there's a lot of things already mentioned, and I fully agree to all of you. But I would like to bring up a couple of things, and those are standardization and also partnership, as Ulf already mentioned. when it comes to autonomous public transport systems, I believe one very important challenge here is to make sure that all the parts that building up these complex systems are working together as one. And because no single provider or single system will be able to provide all capabilities needed for this to work. And here I believe the Scania's tradition and focus on modularization, developing separate modules that can communicate via standardized interfaces is actually a key factor for this to work. And also then, as Ulf mentioned, partnership, of course, because we can't develop all this ourselves, that's for sure. And I believe actually in the iQMobility project that we have practiced both these things, and especially in the cooperation with our external project partner, INIT then.
Anything else you think is crucial?
Yeah, since I'm sitting literally in the middle of all engineers doing this development on a daily basis, I must also bring up stuff like cybersecurity and scalability for these systems. And that's crucial things to make sure that we end up having a secure and safe and robust system for the future transport system. So, and I mean, in summary, we have a lot of challenges left then, but I really want to emphasize that all these challenges are very fun challenges, and it's not only that we are working with cutting-edge technology, it's also that we can also feel that we can actually here contribute to the shift towards a more sustainable transport system, and that's really important to emphasize here, I believe.
Thank you, Jonathan. I'm now actually going to ask my last question, and I'll ask it to all four of you. However, I can see that we are running out of time, so I'm going to ask you to be quite short with your answer. But we did promise at the beginning of this seminar that we would give, this webinar, that we would give the answer to the question, are we ready for autonomous public transport? So why not start with you then, Jonathan?
Okay.
Are we ready?
Yeah. I mean, we have obviously discussed a lot of challenges left already, but I want them to stay positive and say, under the right circumstances and in small scale, yes, we are ready to start.
George?
Same answer. We're ready to start. We have a lot ahead of us, but it's going to be fun, the journey getting there.
And then maybe you, Ulf?
Yeah, I think for the more it will take some time for the more complex user scenarios to be completely ready. But for the more easy use cases, we are ready to start now with making also pilots on public roads, and that will happen soon.
And Anna?
Yes, I agree with the three others. I would also like to add that we should, of course, start the journey with now, or we have already started with the simple use cases. But I think we should also keep in mind what problems can we solve? How can we get benefits from the driverless systems already now? And we will need both tests that are in simple environments and providing simple services to test the services and to test the user adoption, but we also need the progressive technology tests. And those two are probably different tests, and we need to do both of them.
So by that, I want to thank all four of you for this final session and for the whole webinar, your contribution. We have now come to the end of this first part of the webinar, I should point out. And we have, during the last 2 hours, covered both the vehicle technology and the system perspective. And we have now also tried to answer the question, are we ready for autonomous public transport? However, if you still have questions, please feel free to use this email address and send an email to either George or Jonathan, the project leaders for the iQMobility and iQPilot projects. By this, we, Scania, together with our partners, KTH, Ericsson, INIT, Veoneer, and Örebro University, want to thank you for joining us this first part of this webinar. It's now time to take a lunch break, but please don't go too far away because we will be back again in 1 hour at 1 o'clock, and then it's time for the breakout sessions. So there you will be able to see, join 4 different streams that you will see on the screen, so stay on this web page. However, I will not be joining you this afternoon, so I would like to thank you for watching. Goodbye, have a wonderful summer, and stay healthy.